In today's video, I will talk about calculus. In calculus, we will start with the first chapter, limits. So let's first introduce the idea of limits. Let's think about a function fx equal to 5x plus x squared divided by x. So we can factor on the top, and we can see this one fx. X and x can be cancelled if x not equal to 0. And if x equal to 0, this function will be undefined. So the graph of y equal to fx is a straight line, y equal to x plus 5, with a point 0, 5 missing. This point is called a point of discontinuity of the function. That means it's discontinuous at this point. So however, even though this point is missing, the limit of fx as x approaches 0 does exist. So here we introduce the idea of limit. So in particular, as in this case, as x approaching 0 from either direction, from left-hand side or from right-hand side, y equal to fx approaches 5. So we write limit x approaches 0 fx equal to 5. So here is equal to 5, and it reads the limit as x approaches 0 of fx is 5. And in grade 12, we have learned rational fraction. So we actually are familiar with the idea of limit when in grade 12. So from the graph, this rational function, we can see the function has a vertical asymptote x equal to 4 and has a horizontal asymptote y equal to 2. Both of these asymptotes can be described in terms of limits. So we have as x approaching 4 negative, that is x approach 4 from the left-hand side, we have fx approaches negative infinity. And when x approaches 4 from the right-hand side, or x approaches 4 plus, fx will approach positive infinity. And when x approaches negative infinity, fx approaches 2 negative. And when x approaches positive infinity, fx approaches 2 on the top. So this is how we write. We have limit x approach 4 negative fx equal to negative x, and the limit x approach 4 plus fx equal to positive infinity, and the limit x approach negative infinity fx equal to 2, and the limit x approaches positive infinity fx equal to 2. And here we introduce some new term, that is left-hand limit and right-hand limit. It's pretty straightforward. So as you can see in this function y equal to 1 over x, we have the right-hand limit is positive infinity, and the left-hand limit is negative infinity. And we say if the left-hand limit is not equal to the right-hand limit of a function, the limit of this function does not exist. So in this case, the right-hand limit and the left-hand limit both exist, but x approach 0 of this function does not exist. We also discussed limit of rational function actually in grade 12. A rational function is the one, the top and bottom are both polynomials. And in grade 12, we have to discuss the end behavior when x approaches infinity. So we know that if the degree of p is less than the degree of q, the limit is 0, right? For example, this is x minus 1, and this is x squared plus 1. This is infinity, and this is infinity squared. So compared with infinity squared, the top is relatively small, so the limit is 0. And if the degree of p and q are the same, divide the coefficients of the terms with the largest exponent. That means, for example, in this one, when x approaches infinity, 1 and x is relatively very small, so you can ignore them. So this one becomes 5x squared divided by 3x squared, that is 5 over 3. And we have third, the degree of p is greater than the degree of q, the limit is infinity. That's very straightforward. And we also need to discuss the limits of trig function. So we have rule number 1. When x approaches 0, sine x over x is equal to 1. So here x is in radians, not degrees. Or you can think it as when x approaches 0, sine x is almost equal to x. So for example, in this one, x approaches 0, sine ax over x. So sine, when x approaches 0, sine ax, you can see it as ax. So ax over x is a. And in this case, sine ax you can see as ax, and sine bx you can see as bx. So the limit is a over b. And the rule number 2, limit x approaches 0, cosine x minus 1 divided by x is equal to 0. We can see how we prove this one. So we know that when x approaches 0, the bottom is almost equal to 0, right? And the cosine x is almost equal to 1, and 1 minus 1 is almost equal to 0. So it's 0 over 0 case. These two are both relatively small, so we cannot determine. In order to prove it, we can times cosine x plus 1 on top and bottom, and the top become this, and bottom become this, and it becomes this and this. And we know that when x approaches 0, sine x is equal to x. So we can cancel this. This becomes negative sine x. And when x approaches 0, we know that top is close to 0. And the bottom is close to 1 plus 1 is close to 2. So 0 over 2 is obviously 0. That's how we prove it. So let's do some practice here. So first one, x approaches 6 of this function. So normally we will factor this one. So after factoring, it's very obvious that the limit can be changing to this one. This one, the limit does not exist. And the second, after factoring and cancel, we know that the limit is 4. And lastly, let's see a piecewise function. This function, when x is smaller or equal to 3, is this, and x greater than 3 is this. So we have to find the left-hand limit of f and the right-hand limit of f, and see if the limit exists or not. So we can calculate the left-hand limit when x approaches 3 negative is 4, and the right-hand limit is 5. So here, this case, left-hand side and right-hand side does not equal, so the limit does not exist. In fact, if we graph this piecewise function, we can see when x equal to 3, it's discontinuous, right? We can see more practice here. So x approach 0, this one. We know that actually when x approaches 0, tangent x is almost equal to x. So tangent x can be seen as 7x, and sine 5x can be seen as 5x when x approaches 0. So it becomes 7 over 5. And lastly, this example, so sine can be seen as sine 7x can be seen as 7x and square, right? So square. And this one is 11x squared when x approaches 0. So it becomes 49 over 122. Okay, thanks for watching.